Craft? Yes.
Yeah.
Hey everybody. Oh, there I am. Sorry, I'm in the dark void of space. How's everybody doing? I remembered to change my title this time. Is my right mic on? Wait a second. It is? Oh wow, okay. Oh no, that makes sense. That makes sense. How are you guys doing? What's up? Okay, this is a little loud. Let me turn this down just a little bit. I'm gonna be doing some math because I got really mad at my professors and I decided I should probably do some math about it. I could be evil. I won't get into the drama, but let's just say that I'm probably going to be releasing a E&M course at some point online, I think. But I'll probably do some other stuff first, probably linear. Just because I like linear and I feel like linear should be taught earlier than it is, or at least the basics of it. Because it's really fun and it's really like useful, and it's actually not too hard, so. We're gonna be doing linear today, but some of the harder stuff. I am sad to say that there is a specific way that I'm going to be doing some of these problems. Oh, there's ads? Shit, wait, what? They can put ads on my shit? I didn't let them run ads on my shit. Does Twitch run ads if you don't have ads on? I specifically put ads off, I'm pretty sure. Publish VODs, enable clips. Allow raids. Where's ads? Brand? No. Schedule? No. Oh, affiliate. Ad-free viewing. It literally says allow. Oh, it says subscribers. Fuck that. That used to be. God damn it. That's literally so awful. I'm so sorry. Literally the whole point of me fucking doing this shit was so that people wouldn't get ads on stuff. God damn it. Okay, I'm sorry gamers. That's not something I can control. But yeah, I was saying there are gonna be problems I do today with a certain way that I'm going to very pointedly say is not the correct way to do it, and I would not think about it that way. Well, let me be a little bit nicer. It is a way to do it, but it's like a shorthand, and I personally don't like it. So, you know, I think that there's tremendous possibilities that exist in shorthand, but mostly for people who do stuff a lot. So not, you know, not something like this where we're only doing a couple. But that's okay. we'll still have to do it because for some reason he wants us to do it, so whatever. Alright. Let me pull up the stuff. Oh, I'm really big today. Let me get a little smaller. I'm gonna walk a little bit further away from the camera. Oh shit. I walked a little too down. Okay, that's not too bad, right? And then we're gonna play Minecraft because, you know, why wouldn't I do that? Okay, let me just drop everything and then rescale this. Can you tell I'm like prepared for stream? Oh wait, was that scaled properly? Oh, it is scaled properly. Wait, just go back. Oh no, I thought that was scaled improperly. Oh, yeah, it's fine. Okay, let's see. What are we doing today? I gotta pull up some shit. How was your guys' day? How you guys doing? What's up? And I also gotta do the Dropbox. I've been losing a lot of sleep, so I'm just a sleepy little dude. If I like yawn and shit, oh, I'm already doing it because I'm talking about yawning. That's why. Okay, so this is probably the right thing. I think it's the right thing. I don't think we're gonna get to homogeneous differential equations. Bonjour. Oh, hi! Oh my gosh, Kazu, how's it going? Okay, I said, I probably have mild dyslexia, so if I ever, like, say, like, Kazu, and that is not K-A-U-Z, will I be rocking and stoning today? No, I will not be rocking and stoning today. Actually, kind of. I'm gonna play Minecraft later, but I'm gonna be doing, math first. So, if you want to learn some linear algebra, feel free to stick around. If that's not your thing, then no worries. I'll actually probably do Deep Rock, like, as a more of a thing over the summer, because I did find it fun. But yeah, just because I don't have that many streams, I try and, like, these days, I try and do, you know, a good amount of math, a good amount of, other stuff. I'll be looking in and out? Yeah, no worries. Okay, here we go. Let's start. So, the kind of goal, I guess, of this little chunk of content is, we're moving on from just any old matrix to specific types of matrices, which is, you know, we talk about that a lot too. It's not really a new thing. It's just a different kind, right? So we're going to be looking at matrices as transformations. So like, kind of like a function, you know, in computer science where you have an input. So for these, we're just going to be looking at, like, for example, this problem is, if we have the matrix A equals 0, 1, negative 1, 0, like, what does this do to the space? What does this do to the vectors that we put into it? Drown him Friday? Oh, I do have liquid! Oh my gosh, and it's not Friday. I got excited. I thought it was Friday for some reason. I want to have a little toggle on my Damie 2.0 that's like a drown him Friday, where I just get what kind of liquid, hydro homie or soda sauce? I have a lemonade, a pink lemonade. Okay, because hear me out. I was gonna get vitamin water, and they didn't have any. Okay. I wanted extra electrolytes, and then they didn't have anything, and I was like, I don't want to get like Gatorade or something, so I got a little juice. I got a little lemon juice. Because I had a doctor's appointment today, and I try and like be kind to myself on days where I have doctor's appointments. Davey juicing up. That's funny. That's silly. Okay. I'm just putting in the standard basis vectors, so the question is asking for sketch the transformation of the square with vertices. Wait, okay, never mind. They want a square. Fuck you, I guess. Or fuck me, I don't know. 1, 1, 2, 1, 2, 2, and 1, 2. 1, 1. So that's gonna be 1. And this is gonna be -1. So let's just draw the square first. Why the hell not? It's gonna be this, 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 this. And then I don't know, let's not even do it on, let's just do it on the same fucking thing. So 1, -1, so this one goes down here. 1, -1. I already forgot the other one. 2, 1. So that would be 1, and then -2. 1, -2. This actually might be a little bit better to draw in different colors, I'm realizing. We'll do that. So 2, 1 is this point. That goes to here. Then we'll have, I don't know, 2, 2, I guess. Which is 2, -2. And that can be yellow. It's kind of a green still. So we got 2, -2. It's down here. So it looks like we're turning it and flipping it. And then red, we're gonna have 1, 2. It'll be 1, -2. Wait, what? No. 2, -2. Wait, what? No? What? 2, -1. Nearly summer quarter. I got some rocks that need stoning. It's not nearly summer quarter. It's a while till summer quarter. As sad as it is to say that, it is. Oh, it's a bit, guys. It's week 7, so we're almost at week 8. Then I have 10 weeks of classes, and then there's 1 week of finals, and then I don't get home till like a couple days after because I'm gonna see some family before I leave California. And then I'll be doing it. I might also, God, I don't know if I want to wait or not, but I am gonna be prototyping for a like a prototype I have that is due on July 1st. And I might just put a 3D printer cam. Because I feel like that could be kind of fun. Getting raw dog by school. Here's the thing, is like my summer is, everybody else's summer is like June, July, August, right? My summer is basically July, August, September. Because I don't go back to school until like September 28th or something crazy like that. So it's not like I don't have a long summer. It's just kind of all shifted over. Can I explain this a stack? Okay, I think, actually kind of explain a stack. It's a queuing thing, right? Like the first in, first out, first in, last out. What I kind of just think about it as like, you're just kind of like stacking things on top of each other. And this kind of makes sense for push pop, because the idea with like, there are a bunch of different things you can do to a stack, right? A stack is basically just like a queue, except you can do some extra stuff with it. Like, it's like a list. It's like if you want to put in something, right? Like you're pushing to the stack. And then if you just want to get the first thing that you just put in, like back out, that's pop. So it's like push pop, right? And so that's like if you want to deal with that. You could also have a stack like if that it's full when you put something in, right? So let's say that this is our kind of in, and this is, you know, we don't know where our out is. So we just put something in, then it pushes this last one out. That would be first in, last out. Right? Because it's the last one we put in. But if we had first in, first out, that I believe would be like we put this in and this top one pops out. I believe. I think that is the way to that's the way stacks work. I think there's probably some good YouTube videos on it, like a good visual explanation of it, probably better than I can do. Honestly, I have not coded in a while. I would like to on both like possibly as like a series if I get good enough at like explaining stuff, but mostly as like a kind of exploration type series is like I really want to learn how to write web servers and like what web servers are useful for which applications, because I want to do projects that have like, you know, potential like AI implementations or just general data storage or like control by app or like other stuff. So, you know, I'd like to look into it, and it's really a space that I haven't done anything in, so. I use TypeScript? Do I even know what TypeScript is? Let me Google it real quick. Who is pinging me? No one important. TypeScript. JavaScript? Huh. I don't think I've used TypeScript, no. I haven't coded in a long time. The last thing I could. Can you explain whether it's better to eat pancakes in a queue or a stack? Because it seems like a stack-based pancake system would leave the first pancake soggy, but it means the last pancake is freshly warm and tasty. But queue means consistency to the pancakes. I am gonna say I feel like a queue is the best. Because if you have a stack, like, you're not gonna get to, like, the bottom, like, very quickly. But, like, by gravity, a stack is, like, the way that you eat pancakes, you know? Make a gay fanfic writing AI? If I was gonna make an AI, I would not... Okay. This is kind of, like, high-level math stuff that I don't even understand, to be honest. Like, I think it's funny trying to look at some of this stuff, because sometimes people don't know. Or just don't know how to, like, explain it other than just saying math stuff. And I'm like, you can say math stuff, but, like, also, like, I kind of want to know more of a logical thing. My background in AI is in generative images, which is kind of funny, because that's the thing that everybody hates right now, right? But I did it before there was stable diffusion, which is a crazy thing to say, because I'm very young, and I was just doing AI when I was really young. Right? So I was working with generative adversarial networks, which was sort of the predecessor to stable diffusion, which is the algorithm that most people use. And I really liked it, because I think that the idea of having like two separate networks within a network like working together to better themselves in a, you know, philosophical sense is just kind of a cool thing. But I mean, the issue with that is like there's a lot of room for what's it called? Essentially like flat outputs, right? Like you're putting stuff out and the AI just ends up learning that there's one thing that it can make to output and satisfy the conditions you give it. And that's bad, right? Because we want it to be able to generate like new things, right? But if I were to make anything in AI, I would do a translative GAN, which has been done before. Like there are some that were trying to like turn like when you put in a picture of a horse, it puts out the same picture, but the horse is a zebra. I want to do a translative GAN that turns people into Muppets. And I want it to be like seed-based, right? So the idea that it's a flat thing is a good thing in that case. Like I want like everyone to like be objectively assigned a Muppet that they are. Like if you put in a different picture of yourself, I want it to know that you're the same person, and it just gives you the Muppet that you are. And that's a really hard question. But like if I was going to do anything in AI, I would do that. Or I would create life, because that one is like my Frankenstein monster thing, which is like, once I am old and like I have a wealth of knowledge in things, I would try to do my Furby child, which was another idea I had when I was learning AI, which would just be an alive thing. But that's a question. That's a rant for another day. So data structures and algorithms seem useless to learn nowadays with ChatGPT. No. They're never going to be useless. The more AI comes around, the more that that skill is useful, because you'll be able to fix the AI. You'll be able to understand it, right? It's a good field to go into, because like your job won't get fucked over by AI if you're the person making the AI, is how I see it. I'm gonna be the Muppet God. I wish I could be the Muppet God. Just the implication of Muppet God in general is really funny. Computer science is dead now? It's not dead, it's just really oversaturated. Damie, have I ever said I want to scruff your model's hair? Oh my gosh, that's actually really nice, because this hair took me forever to do. It took me forever to get ready like this, you know what I'm saying? Like... most would be dead and society would collapse if we had a Muppet God? Oh god, oh fuck me. Wait, how do I even do this? Product of reflection, stretches, and shears. Oh, I think I know what I'm talking about. I think I know what it is. Evil mode? Wait, I have to go and turn on evil mode. It's not like my nice... There we go. This is the budget version of evil mode. I'm so sorry. The other evil mode I have is better. Okay, let's do this. Okay, so I remember doing this actually when I was younger. I say younger, like it wasn't like 1 year ago. It's fucked to think that was a year ago though. Let's just draw this out. There's probably some negatives in there. Evil? Yeah, I'm a little evil guy. I should make some little devil horns. I'm not too scared about AI, because if it gets to that point, not even AI jobs would be safe, because there'd be like one for every 10,000 person studying AI, and every other person wouldn't be contributing to the economy. Capitalism would collapse, and we'd all be in Mad Max, or it just turns into communism. That's where I hope we go. No, it's funny though, because I was doing a production, so for my manufacturing class, normally we do single part production. So like we have a part and we have to go through all of the different routing steps to manufacture it. So it'll be like a bunch of different operations. Right? But we were doing a production run. So we had to make, as a group, 12 of the same part, and we each had to do like one operation, right, until it was done. And it really just puts it into perspective, like, holy shit, we could automate literally everything, and the jobs like this, people wouldn't have to do them. And we wouldn't have to pay people less for these jobs, because, like, we could just have robots do them, is the thing. Like, and it wouldn't be a big deal, which is, you know, kind of crazy. But obviously, for some small stuff, it's like you kind of realize that it's not really worth it to do. Okay, why did I draw those two? It's not really logical to do it, because if you're only making like 5 of a part, it would be really hard to do like a whole production scale for it. But comrade for real. I was gonna do, I don't think I ever talked about this. I was gonna do like a ASMR Karl Marx reading stream. That was one of my first, that was one in my stream. Dude, do it. AI and robots could never replace us. Yeah, I don't think AI and robots can replace humans. Because at the end of the day, like, you're still gonna... You'll long for the touch of a human, is what I will say. I would not worry. I think a lot of people like fearmonger because they don't know about, no AI can replicate Damie's mad gaming skills. No AI can be as fucking bad as I am. I told my roommate I died 11 times on the second mission, and they said I didn't even know it was possible to die on the first couple missions. Oh, it was not my proudest moment. We should make an AI that's just blind, actually. Wasn't even hard mode, it was stop, I'm not a gamer, guys, I'm not a gamer, okay? Imagine if you went up to your professor in real life and was like, hey, why aren't you good at video gaming? And they were like, why are you asking me this? Except imagine if you saw the same professor game. That's one of the reasons why I wanted to stream, like, math stuff and also stream gaming, because I just thought it would be so funny that, like, you just see your professor, like, gaming. I don't know why it's so funny to me. Wait, okay, let me think about this. So 1, 0 would be 1, 0, and then this one, if it was 0, 1, it would be, wait, let me just stop being a little silly, little spongy. I hope everybody is ready for the return of Crush Crush, because that's really what this summer needs. Oh, what am I doing? 0, yeah, okay, there we go. Yeah, no, I figured it out. I don't know why I was doing dot product with only 1. Ugh, okay. So yeah, 0 minus 2. We're gonna do that, and so our blue vector is gonna go to minus 2. This is straight up just a rotation. Sorry, just a scaling. It's just flipped. Now to do this as a rotation, you can die in Deep Rock. Yes, Umbra, I died in Deep Rock a lot, okay? I'm very bad at shooting. I feel like I've said, ooh, if it's on sale right now, oh, I might buy it. I said this to my roommate. I have never played an FPS game, ever, before. Like, I literally have never played an FPS game. That was the first time I've ever played any game where it is first person and I am controlling a gun and shooting stuff. That's not Minecraft with a bow and arrow. The only shooter game I have ever played was Splatoon, and that's not first person. I'm just cracked like that. Deep Rock isn't even an FPS. I know it's not an FPS, it's just I've never played a game where I shoot things. Oh, Far Cry 6? Okay, here's the thing about games. I can really only have one game I'm playing at a time because my, like, ADHD brain, like, won't let me do anything else without being, like, just, I can only do one thing at a time, so. You don't even need to shoot just mine. What about all the bugs? There are bugs in it that you need to shoot. You're lying, you're gaslighting me. You do need to shoot. Okay, we're starting eigenvectors, by the way, just so you know, just so everybody knows. God, I'm gonna cry at how bad the proof was for eigenvectors and eigenvalues, guys. I care so much about math. Oh, God, okay. 20, I think is. Okay. You need to shoot and hit your target. Mr. No Ammo. Yeah, I'm not good, okay? It's funny because, like, I'm so bad that, like, it's honestly kind of pathetic even to, like, dunk on, like, my skills because I just don't have any. Like, I'm sure if I, like, spent time, it's not like I couldn't be better. It's just, like, I just am woefully bad. Now see, if they asked you to do an eigenvalue problem in the middle of it, you know, to fix the fucking pipes on the ship, oh, we're chillin'. We're absolutely chillin'. I would take care of that shit in a heartbeat. Okay, here's... Pains me to do this, chat. Okay, I have to stop talking about deep-rock for 1 second to explain one thing. Okay. When you're looking for eigenvalues, eigenvalues are specific values that when you multiply the eigenvector when you actually transform the eigenvector, it just turns into a multiple of itself, right? So like in this one, for example, right, you can see like this is an eigenvector because it didn't move. We didn't like put it off the axis here, like it didn't like, you know, go crazy in 3D, you know, all these crazy things. This one's also an eigenvector because we just multiplied it by -2 of itself. Which makes sense because this is a diagonal matrix. So we're looking for specific eigenvalues that'll give us this thing, and that's kind of hard to do. So what we do is, there's a proof for this that I would do if I was doing a lecture, but you find out that if you do A, your matrix, your transform, minus lambda times the identity matrix, so like a diagonal matrix of eigenvalues, then you can take the determinant of this and set it equal to 0, and you can solve for your eigenvalues. So what that would look like is, I always do a little funny little arrow whenever I do something that's not just equals. Right, so we're gonna do 10 minus lambda. We just subtract off the diagonal. 0, 2 minus lambda. And this one's not even that bad, so I can like show it both ways. We want to take the determinant, right? So these all look nasty as hell, except for the middle, right? Because we can take a determinant on any column or any row. So I'm going to use this middle because there are 2 zeros there, and that makes my life easy as fuck. So we're going to do that. We're going to do the determinant. And that's going to give us, right, we take out the 2 things, so we're going to have -6 times 10 minus lambda, minus, and I'm looking at the corners, right, so I cross out these 2, minus -8 times 8. And this is going to equal 0. And this comes from the fact that we want this matrix to not have an inverse, which sounds kind of weird, but we don't want it to have an inverse. So if it is invertible, then its matrix would not, its determinant would not equal 0. So we're gonna have -60 plus 6 lambda, and then this will be plus 64. Equals 0. Really easy. Wait, I need to multiply by, I think I need to multiply by, yeah, I think I need to multiply by 2 minus lambda, this whole thing. And also, is it negative? No. 2 minus lambda. Don't mind me forgetting how cofactors work. So we have 4, right? So 6, 4 lambda, 4 minus 6 lambda plus 4. So actually, we don't even have to like, this factored itself, right? So we get lambda equals 2, and then lambda equals 2/3. So we can find the lambdas that way. Now, I'm sighing so much, chat. This is like a proven way, right? The reason why this works is because if we want to say a times v equals lambda v, and we want to solve this equation, we can do AV minus lambda V. But this isn't a matrix, right? So we need to make this a matrix so that we can say, we can factor this out to make it equal 0, because we can factor a V out, right? So we're going to say A minus lambda, and we're just going to pretend that this is somehow a matrix, just for now, times V equals 0. And the way we make it a matrix, right, is we just multiply by the identity matrix. Because when you multiply by the identity matrix, you're not changing anything, you're only just basically, by taking the dot product of this, you're just multiplying each column by that. So that's how you get the A minus lambda IN. That's like a proven thing, right? And we know that that equals 0, right? Because this V is not going to equal 0. This is going to be whatever V we put in, so we need this term to be 0 to make this true. So that's why that works, right? So that we can do all this. And you'll have to trust me that the determinant thing, the inverse thing is true about that. But there's another way you can do it, which sucks, and I hate it. But for some reason, my professor wants us to do it this way, which is, okay, so you know that you're gonna have 3 terms, I guess. Because, you know, you can just easily look at it and see the determinants really fast. But, so you're gonna say lambda cubed, and then you're gonna say minus the trace of A times x squared, then plus the 2x2, adding the 2x2 determinants, all of the 2x2 determinants in this matrix, and then plus the determinant of the matrix. And to me, see, here's the thing, right? These problems are all rigged, right? These are all going to be nice eigenvalues. These are all going to be factorable things, especially if it's in a textbook. This is so much faster than doing this. I don't know why you would do this. You have to go like, okay, 10 times 2 times minus 6, that's like, what? You know, negative 120, so you got lambda cubed, plus 120 lambda squared, plus, you know, and then you have to do like this, and I don't know why you would do that. I think it's stupid. So I'm not gonna do that. But I have to do it at some point, so I'll probably do it later when there's not a really easy matrix to do. What do they even ask for? Just the oh no, also the eigenvectors. Then we just have to find the eigenvectors, we just have to plug in the eigenvalues. Badmouth my professor on stream. I badmouth my professor to my other professor. Guys, I go to 2 math lectures, okay? I'm enrolled in one class, and I go to another lecture, like, right after the lecture that I go to. Because it's so much better. When are you going to teach us how to cook meth, like Walter? I can teach you, this is what I learned in chemistry. If you have hydrochloric acid, and you add NaOH, you can do a double displacement reaction, and these will switch partners, because this is an acid-base reaction, and you'll get NaCl, and that's wrong. That's wrong. I'm not even gonna pretend like I know how to do chemistry. I don't really know how to do chemistry without having problems set up. Chemistry is like magic to me, in a good way. That's acid-based. What's acid? Cringe. Okay, that's good. Chemistry is actually, I feel like it's very funny. I feel like it's a very funny field of study. Like math, there's not a lot you can joke about in math. I think the one math joke that really just made me actually laugh was send removable discontinuity, which is just one thing. But like chemistry, I don't know. I feel like there are a lot of funny things in chemistry. Also explosions. What's not to like, right? Math is like very, math is like the dad jokes of STEM. You can write boobs on a calculator? That's true, that is funny, you're so right. That's so, you're so real for that. Sorry, I'm just... Look at that, wait, that, no, that's positive 12. Yeah, but real boobs are made of chemicals. Chemist still wins? So real. I'm made of chemicals, guys. Did you know that? Okay, so we have a rank 1 for this matrix, right? Because we only have one important vector. Yeah, but this ratio is math? Oh my god, you guys are fucking better at doing math jokes than I am. Don't even listen to me. So we get x equals 12y over 8 minus z. And so one of our eigenvectors is, I just made the null space. The eigenvectors represent the null space of the eigen transformation things. That was probably about the worst way I could have explained that, but we're just gonna pretend like it was good. Why did I write that like that? That's weird. So we have negative 12. I'm only here to pretend to know what you're doing and make jokes. That's so base though. I need somebody to do that. You know, when I do lectures, I swear they'll be like actually good. As an engineer, I hate math. Umbra, you make me sad. Not like you specifically, but like that makes me sad because like every engineer I know like hates math and it makes me depressed as hell. Math is so cute, guys. Math is like a little here's math to me. Let me like make my tablet not bad for 1 second. Wait, I'm on the wrong. That's not, he's got his hands behind his back, I think. Or in front of him. This is math. Math complicates the engineering process. Engineering needs math. Math is how we describe anything that happens in the world ever. You speak in trig functions. The way that we produce sound is trig functions. Like, everything is math, and it's beautiful, I think. That's so sad. Egg, I'm gonna cry if you say that. Math is my best friend ever, okay? Also physics, but like, it's really hard to like physics when your professor hates math. You can tell when people hate math very clearly, and it is not a good color on people, I will say. Does not bring out the eyes. I'm not sure if I did this wrong. I should check. Because 2/3 seems like it would be bad. Don't think that's right. Let me see. Negative 60 plus 6. Yeah, that seems right. I feel like I should have another lambda in there though. No, maybe not. Huh, let me see. I definitely copied everything down right, because it worked out for one of them. I just don't like the 2/3. When I'm gonna upload my Linear Algebra 101 course to Udemy, God, never to Udemy. If I make anything that's not free, I'm gonna have to have a stern talking to myself. If this is 2/3, then it'd be like 9 1/3, negative 12, 8, 0, 1/3, 0, and then negative 8, 12, negative 6 and 2/3. Oh, I switched my color. I don't think that's right. Because these are supposed to be multiples of each other. Unless they're not, but I really doubt they would do that. I hate fractions so much. Fractions are a little goofy, silly little goofy little dudes. I have gotten to a point where I really dislike fractions a lot, dislike decimals a lot more than fractions. Because it's just like, it's rough. I don't like truncation, and fractions are like perfect, right? Like, you know that this is, you're cutting something into 8 pieces and you're taking 12 of those pieces. And you're never gonna have like shitty things. You can just leave it in terms of this. Like, you can leave this in, you know, 6/4, or not even 6/4. You can leave that in like 3 halves. And isn't that great? Why did I not write that as 3 halves? Why did you guys not get on my case for that? Put that 3/2 in there. Who wants a fractional unit of something? Whole ass or no ass? Okay, goodbye to filling up a 1/4 gallon of a tank then. You only can fill up... This is like in Minecraft. They won't let, like, okay, you have a machine. You can put a bucket in the machine, right? Because you can only put the entire bucket in the machine, you have to wait for it to completely... Like, even if there's just a little bit left, it won't even let you put the whole bucket in, because there's no unit that is less than a bucket if you're just holding a bucket. That is what you want. That's the future you're describing. I'll come back to this later. It's, this one is done right, though. The 2-1 is done right. Yes! Egg doesn't want to bake anymore. No cooking in increments of... The entire world would stop functioning. You know, everything can be a whole number if you think about it. If you just choose the smallest... You can just say, like, your unit is 1/2, and then you have 3 of your units. Just change the basis. 1 pound each ingredients. Oh, that's funny. 22. Okay, we can do 22. 1 pound each ingredients. I should probably try and see if I can figure out the fucking... He literally calls it the secret trick, and it pisses me off so much, guys. It pisses me off so much. Oh, you rarely, like, I will rarely get mad at people. I was so mad today at my math and physics professors. I got a headache because of how mad I was. Look, this is also a nice determinant to do. We're gonna get 1 minus lambda and, like, times some other shit. It's gonna be so easy. Damie nearly burst a vein. I was like, I'm gonna get a hernia if I keep carrying this. Hulk mode. 5 secret hot tips to spice up your math life. That's so funny. Oh, I definitely wrote some... No, I didn't write something wrong, because it would be just silly up there, I guess. And then this will be +4. That's the kind of YouTube shorts I'm gonna make. 5 secret tips to spice up your math life. Just get really nasty with trig. I feel like trig is like the least liked math. But maybe that's just me. I feel like people dislike trig the most out of like the easy maths. I say easy because it should be easy. Oh, I died. Apparently. Oh, I'm back. Okay. That's the evil Damie. That's the Shadow Realm Damie that we don't talk about. I don't know why I just forgot to write the 1 there. Oh, this will be lambda squared. Minus 2 lambda. Plus 1. The secret tips we got taught in math was just the normal way of solving it. That's the funniest thing, is he makes it seem like a secret trick, but it's just like the normal way of solving it. Damie revived in 3 seconds. Jesus, took 3 days. Ooh, we have multiplicity 2, guys. It's not gonna be diagonalizable. Fuck. Okay, so lambda equals 1. Wait, what? We've multiplicity 3? Oh no. Did I do something wrong? No, I definitely didn't do anything wrong. Okay, guys, this matrix sucks. This matrix sucks at life, sorry. No, it doesn't, it doesn't. Diagonalizable is a very large word that is very hard to say. Basically, it means that, okay, so we have a matrix of nasty stuff. Not nasty stuff. Lovely things. But it's not really useful for us to, it sounds like a Pokemon! Oh my god, I would have math team Pokemon. Dude, that'd be so fucking awesome. Anyway, basically we have a matrix full of stuff. And, you know, if we put this into a computer, like a computer can multiply it, right? Like, that's no biggie. But sometimes we want something that is like serendipitous in like how we can multiply it. So like what if, hear me out, what if we just had a matrix that was like A, B, C, and everything else was zeros? Like what if? Like wouldn't that be so cool, you know? Because then if we put a matrix into it, all we have to do is basically just take this number, like if it's 2 or something, we just say 2A. And like if this is also 2 and 2, then you just put the constants in, right? Like it's really, really, really easy to do. So it turns out that if you have a matrix that has enough eigenvalues to populate its diagonal, which sounds like a big sentence, if you have enough of these lambdas, right, that are different, that you can put them in, each on the diagonal, you can actually write the matrix as like this. 3 zeros here. And this is the exact same transformation. And that sounds crazy. You're like, Damie, those are different numbers. You're wrong. And you're right, because it's not exactly the same matrix. It is the same matrix, but what we've done is we've changed the place the matrix lives. We've changed what the matrix refers to so that this is the same transformation. So each matrix has a basis, right? Where it lives, how the vectors are, like what you're comparing the vectors against, right? When we write 1, 2, 3 and we don't put anything on it, we assume that this means like, you know, 1 in the x direction, 2 in the y direction, 3 in the z direction, right? But we don't have to adhere to that. We can have whatever thing we want. That could be like, if we had a thing that was 1, 2, 3, that could be like 1 times 52, 3, 0. If I had a teacher like you for math, I feel like I'd pay attention, but I don't think I'd learn more. I think you would. It depends. Being out of school is like, once you're out of school, I feel like it gets hard to learn stuff unless you are really passionate about learning stuff. But yeah, we basically just changed the basis of this to make it so that this matrix is the same matrix, which is really cool because we can just do stuff with this now, and it's the same thing. And we can put in any vector if we put it in the right basis. Now I know you're like, okay, well, it's probably not trivial. Oh, did somebody fall? Oh, hey, I heard my TTS go off, which almost never happens. God, I forget. Oh, fuck. Where's my fucking thing? I've said the fuck word so many times this stream. Oh, creative and unique username. Thank you. I like your username. It's creative and unique. Okay. You're like, Damie, this is great, but it's not trivial to find that basis, right? It can't possibly be trivial, right? This is so specific. Like, how could we possibly generalize? We know that this diagonalizable matrix is similar to A, right? So that's just a definition in linear algebra. That means that S inverse, it's S inverse AS or S times SA inverse, something like, I think it's S inverse AS. It's just a definition that's saying like these two matrices are linked, right? We can kind of move back and forth between them. It's our change of basis matrix. And this is our new basis, right? And it turns out that when we find the eigenvectors that come from our eigenvalues, they make up this S matrix. And that becomes our basis for our space, which is really cool. So what we can do is say, when we found lambda and we want to plug it in, right? Let's just plug in lambda equals 1. We get 0, 0, 0, 0, 2, 2, 2, negative 2, 0. And that means that we'll get, by doing linear algebra, we'll do y. So 2y plus 2z equals 0 is what this means. And then 2x minus 2y equals 0. Whoa, subscribed with Prime. Oh my gosh, thank you so much. Holy shit. No way. That's wild. Hey, thank you for that. Thanks a lot, man. Holy shit. So we can move this stuff around now, and we can get some answers to what the null space for this is, right? We'll be getting a vector, and that's going to be our eigenvector, and that's going to be what defines the space. Now the thing about this matrix is it sucks, and by sucks I mean that in the most affectionate sense. This is a great guy, but we know that we need 3 eigenvalues to make up this diagonal matrix, right? Because like if we had zeros here, we wouldn't be just doing the same thing. We're losing information, right? Because a matrix gives us some information, and if we only have one thing, we're crushing out the other 2. Like it's only going to give us 0 over here, so that just wouldn't work. So this specific matrix isn't diagonalizable because we don't have 3 eigenvalues. But if we had 3 distinct ones, then we could diagonalize it. No problem. Love to keep an eye out for math streams. Slowly working my way through a maths degree. Tough to chat right now, but I'll catch you again. Enjoying the stream. Oh my gosh, I love math. I'm an engineer. Oh my god, we talked about. Oh, it was so cool. Wait a second, I gotta show you guys this. We were talking about differential equations in my in my lecture. It feels like I'm having an affair on my professor. Like not an affair like an actual affair, but like it feels like I am like stealing away in the dead of night to go like to a better lecture, and I feel kind of bad about it, but like it's a really good lecture, so you know, what can I do, right? But we were talking about the mass spring model, which everybody knows this, right? I was doing this like fucking last quarter. But you can solve this with differential equations, and you can imagine that like this is in a box, and that you're like shaking the box around, like you're fucking getting in there, and you're inputting a specific frequency, right? Like I think we did 11 cosine of 6t, so you have, you know, a wave that you're inputting. And then like the question is what happens to this spring? And you can actually figure that shit out. And like if you have your oscillation in here, which is like dependent on, you know, the spring constant, it's dependent on the other constant in the system. Like let's say it's 12, well, let's say like 5 cosine 6t. If this and this are the same, if they have the same period, then it's gonna like get bigger forever, and it's called like pure resonance, and it like fucks up like your system and stuff. Like it's gonna break the spring eventually. And the fact that you can just like figure that out with differential equations through linear algebra, like you do it through linear algebra, it's like so fucking cool. I don't know. And that like makes me excited about physics again, which is funny because I learned it in my math class, but anyway, that's probably like really intimidating to like hear all of that. I think I still need to find the eigenvectors for this, so we can find the eigenvectors. Doing all this stuff, I'd love to do a linear algebra course, because the really nice thing about linear algebra, this is a specific course that's like linear analysis, so it's also differential, which means you do need to have calculus for it. But the nice thing about linear algebra is like you don't actually need you don't need anything past algebra to do linear algebra, which is kind of a strange thing to think about. But since it's a completely new framework, you don't have to know like calculus. Like you can just skip calculus and like do this if you wanted to. Okay, so our eigenvalues will have 2x equals 2y, so x equals y. And we'll have let's see, this would be 2y equals negative 2z. So wait, y equals negative z. So that means x equals negative z as well. So we only have one free variable, which is kind of nice. It's awesome that I've gone into the shadow dimension. Again, I love that. Cool. Swag. Anyway, it'll fix itself eventually. Alright, so the way we write this, right, is we'll just write what our x is, so we know we have y, and we'll have, or we can say negative z 1. Sorry, negative z, z, and then if we pull out a z out of this, we'll get -1, 1 times r. So we see that we only have one eigenvector, right, which is our -1, 1. So if you have only one, right, it just means that within this transformation, there's only one vector ever that goes to a multiple of itself. So poor little guy's out there on his lonesome. It's a bit sad, but you know, sometimes it happens. If a matrix is not possible to diagonalize, we call it defective, which I think is kind of mean and kind of rude, because it's just doing its thing. Why are you out here like calling it out for that? Like it's just trying to chill. But you know, I guess people just really want to make judgment calls on matrices. We moved past that. It's 2024, 2023. I time traveled, apparently. Okay. Cool. So now we get to do a little one. One of these times I should probably do the traceway. Should I do the traceway, chat? God, I don't want to do the traceway. I don't even remember what it was because it was so dumb that I like blacked out. It's not dumb. I shouldn't say that it's dumb. It's just... he didn't prove it, and because he didn't prove it, I don't trust it. Which is always a good thing, chat. If I ever do a proof and I don't prove it, and I don't link a proof to it, then you better call me the fuck out for that, because gotta keep me on my toes. Oh my god, I wrote so much. I was shit talking so much in my notes. Okay, let's see. Okay, it's yeah, I don't even know if I wrote it the right way, I'm gonna be honest. Let's see. I think I did it. I think I might have done it right. The other thing is he had us do it with complex numbers. I was like, dude, it's already hard enough. Why would you want us to do it with complex numbers? I mean, I get why, because you can factor anything with complex numbers. So all the matrices that are not diagonalizable, actually, sometimes you can have a diagonalizable matrix if you have like, because if you came out to something like x squared plus 4, right? You're like, oh, I can't factor that. What do I do? But you can factor it into 2i, right? Plus or minus 2i. So then you get into the complex space and you can diagonalize a bunch of other stuff. That's a little bit beyond what we do here. Okay, so we're just going to take the determinant of this 2x2. I believe. No, sorry, we take the trace. So we add up the stuff. And we do subtract this. So this will be minus 6x, and then we take the determinant. So this will be plus 8 minus 3. So that'll be x squared minus 6x plus 5. So then we just do a little bit of light factoring. Lambda equals n minus 5, n minus 1. Okay, and so we have two, right? We have two distinct ones, which is good, because we know that that is going to get us to a basis, an eigenbasis. So now we can just go about finding that. So this will be lambda equals 5. So 2 minus 5 is negative 3, 1, and we'll get 3, and negative 1. Look at that. So we're going to get 1, right? Because this is rank 1. So our null space will be 3x equals y. So we'll have x equals 1/3 y. And the way we can write that, right, is 1/3 1. Very nice to know. And then for our lambda equals 1, it's even easier. 1, 1. 3, 3. That is x equals y. No, it's not. It's x equals negative y. And so that'll be negative 1, 1. So then, do they ask that they want to sketch the eigenspaces? Okay. Sure, we can sketch the eigenspace. Oh, sorry, I had to stretch. Let's see. Sketching the eigenspace. It's a little funny, silly, isn't it? Cool, fine, we'll do it, whatever. I mean, we can just do this. I kind of like to write, I don't know, I could do set notation. This is just a truncated set notation. It is notating a set, but it's like, I could say R2, like that. That's just about as much as I would do for set notation. Okay, our eigenspace is going to be, let's draw it in green. We have negative 1, over this way 1, and up 1. So this vector, when it's transformed, is just going to scale to itself. That kind of looks weird. Oh, okay, whatever. And then 1/3, so we'll say that this is 1, and that's like kind of 1/3. And this vector here. So when we put in, this, like negative 1, 1, we can check. We should just get a multiple. So this will be negative 2 plus 1 is negative 1. And then negative 3 plus 4 is 1. Actually, it just scales to itself even. Because that's the eigen vector with the eigenvalue is 1. So this one should be 5/3 and 1 if we tried that. We put in 1/3 and 1. We'll do 2 plus 1, right? That'll be 5/3. Very nice. And then 5. Look at that. So we successfully found some eigenvectors. It'll always work. I personally don't like the fucking secret trick way because it's weird and I hate when people do tricks in math because why are you trying to trick people? It's math. You don't need to trick people. You can use logic and beautiful, elegant solutions that are not, hey, I put this thing in a formula and then I put it in and I figured it out. All right. Let's see. I think we probably just have more. Like, because when you're doing this for 2x2, it wouldn't be that hard to do. Because you're just going to do 2 minus lambda times 4 minus lambda minus 4. Virgin professor destroyed with Damie facts and logic. Oh, I can't do that yet. I'm just an undergrad. I can't, like, call out professors. They've been studying for a lot longer than I am. Okay, let me level with you. The reason why, like, this guy is doing it is because, like, he does a lot of matrix stuff. Like, that's his thing. It's one of his research things, is he works with matrices. And so, obviously, if you're working with matrices all the time, and you're doing matrices by hand, you want to find the fastest way to do stuff, right? So this is fast, like, especially for a 2x2, like, that is a fast way to do that. For me, if you're in a class, right, this is not a math class, this is an engineering class. That is a math class, it's like for engineers. You really want to make sure that people understand what they're doing. So with all of this stuff, with like doing the eigenvalues like this, like knowing how to do that, you know, knowing that it works for like upper tiers of matrices, like all that stuff, that I think is so much more useful for people to know than just like a trick version of it. Because they're not going to be doing this as like their job. Like they're not going to be working with these. Honestly, all of this stuff is going to be done for them. Right? By a computer, because you can just do this with a computer. That's why linear algebra is great, is because it's very conducive to like computing. And computers can do it really easily. lots of like recursive stuff. But like, I just don't understand why you would want to be like just teaching people tricks that aren't really like the real way to do it, because they're already looking for ways to not do things. Like, don't just try and give people like a formula they can plug into, because then people aren't going to know what the hell is going on. People are going to ask them about it, and they're going to be like, I don't know, it's just a secret fucking trick. It's like, what? What? What do you mean secret trick? Like for this one, we could do secret trick, or we could just say, okay, -2 minus lambda times -3 minus lambda times -1 minus lambda plus 1 equals 0. Was that long? No. Was that hard? No. Like, and it's almost all already factored too. You know, like if you start to get into cubics, factoring cubics sucks. Doing this is like gonna be nice, right? Because we're gonna get 3. It's 3 lambda plus lambda squared plus 1. Gonna be rowing while listening to math in the background. Oh, based. Rowing is good. I did it a little bit a while ago, but it's like pretty intense. Okay, the 4 and 4 is kind of rough. It's I think it's 2, right? Lambda plus 2 squared. Okay, so we've got lambda plus 2 squared, which is already not a great sign for how our basis is looking, right? Because we know that's just going to give us 1 eigenvalue. And also negative lambda minus 2 is only going to give us 1. Which is a little upsetting, but it is not possible, I don't think, for this to... Did I do this right? Let me just check. Yeah, -2 minus lambda, and then that times that, minus, yep, that would be plus. Yeah. What distance did I go for? Oh, I just go for like a set amount of time. Not like rowing in real life, it was like rowing on a machine. Although nowadays I just do kind of like lion dance stuff for arm strength, because it trains my muscles a little bit better since I'm doing it mostly for lion dance anyway. So, you know, 0, -1. Okay, this is gonna be kind of weird. Actually, this might be good. Normally, a lot of the times when I would do these problems, they wouldn't give you ones that are kind of like that you have to actually do the null space for, like solving it, but we can do it. We can do it, chat. We can do some reduced row echelon form. Okay, we're gonna flip this and multiply by -1. Don't freak out, it's okay. -5, 1, 0. The 0, 0, -4 is really pulling in that bottom corner, thank God. Okay, R2 plus 5, R1. Also, I was taught to do it this way, and like the book does it like M1, 2, and like A3. It's really, I don't know why the book does it like that. Don't use the textbook that I use for this class. Please, chat. Please, I care about you guys. 8, 0. Nope, I lied. -10. That's good, looking good. I can divide this by 1, or divide this by -4, why not? Okay, so we'll get 4, sorry. 2 divided by 8. You know, it's not super elegant, but 5/4 is not actually the worst thing in the world. Would it be that bad to do... I wonder if I could just kind of... Okay, we ball. You want to try it, chat? Let's see. We'll start with this one. So z equals 0. Nice. So then y equals 0. Wait. Oh, they're linearly independent. How? What? Wait a second. How is that possible, actually? How did I do something that gave me a linearly independent... What? What does that mean? Wait a second, let me think about this. Okay. We got an eigenvalue. And it's linearly independent, so that means, like... there's no vector with the eigenvalue that gets multiplied by that. That's wrong, I don't think. That's right. Unless it's just 0, but that's a trivial sort of solution. I messed something. Do I need a negative, maybe? Would that even fix it? Let's see, because that's 3 and 3, so that'd be 6. So no, we're even. We're in good territory. Huh. Fascinating. Let me stare at this a little bit more. Let's see. -1 minus 2, yeah. Huh. That too. Well, these two are linearly independent. But that doesn't really tell us that much. I guess I could have goofed it on... Oh shit, wait. Wait, negative lambda equals 2. Oh, lambda equals minus 2 on both of these. How did I mess that up on both of them? Lambda equals minus 2. That makes more sense. Okay, there we go. 1, and then, oh my god. Okay, that's funny. Let me rewrite this. Can't believe I did that. That was so silly. I do like these kind of problems because they're very good for just general, like, do you know linear algebra? If you can diagonalize a matrix, you can do anything from this class, pretty much. Okay, so lambda equals minus 2, so -3 minus minus 2, we get -1. So -1, that minus 1 is going to be, we're adding 2, so that's going to be 1. And then 0, 0, 0. So that's close. It's closer. Alright, well. So we'll get x equals, sorry, yeah, x equals negative y. Positive y. X equals y plus 2z. So I guess I could just row reduce this. Yeah, it's not in row reduced form, so I mean, you can still solve it. It's just kind of weird. R2 minus R1. Oh, yeah. So z equals 2. Sorry, 2z is 0, so z equals 0. Then x equals y. So that would be, if we were to write this out, we would get y, y, 0. That would give us 1, 1, 0. So that is our one eigenvector. Now, it says determine a basis for this space, and I don't think it has a basis. But that is kind of not good, because it should, if they're asking for it. What is the... let me see if I can do eigenvalues. Let's just check on a calculator. I could have done a mistake. So what was the matrix? The matrix was... -3. Oh, I have it right over there. Or a 3 by 3. 3. Oops, not -1. Okay. -3, -1. 0, 0, 0, 1, -1, 2, 2. Okay, cool. Let's see. Please just be one eigenvalue. Let's go. Eigenvalue -2 with a multiplicity of 3. This problem is wrong. I don't know why they said determine the basis and give a sketch. It does not have an eigenspace. I mean, the eigenspace is a line, I guess. But we don't have an eigenbasis for the matrix, so. All eigenvectors are just gonna be on one line. And that's the line we just found. This line right here. God damn it, there we go. Oh, we even get to put the Z in, look at that! Except there's writing it differently, it's this then. Wow, most boring eigenspace. Okay, it's not that boring. The line goes on forever. Imagine. Alright. Okay. That's pretty good. I got my rant in about the secret trick, so. Oh my god, it's been an hour and a half? What the hell? I think I'll finish, wait, 7.3, 8.1 is differential. Yeah, we're not doing that on the quiz, so. Probably not on midterm either. Maybe we just get to homogeneous, but I did homogeneous in the other one. Okay, let's just do a couple more. Oh, this one actually is interesting. Wait a second. This is a little bit of a conceptual question, chat. A little bit of a... Oh, I didn't write the zeros in there. Okay, this is a conceptual question. Okay, so we have a matrix that is... Okay. A, B, C, A, B, C, A, B, C. Kind of weird. And it has eigenvalues 0 with multiplicity 2 and A plus B plus C. So determine all the values of the constants A, B, C for which A is non-defective. So non-defective means that it is diagonalizable. It has a diagonal matrix that it's similar to. And that is going to mean that it has eigenvalues that correspond to eigenvectors that are like good, right? So we need to have, for 0, let's see. For 0, it would be... 0 just gives us 1. So we need to have A plus B plus C give us 2 eigenvalues. And the way that I saw 0 equals 1, right, is if we do this, right, if lambda is 0, then we still have A plus B plus C, A plus B plus C. So if we row reduce that, we'll get A plus B plus C. Oh shit, wait, actually maybe there's... No, this gives us 2. It's 2 free variables. So this will be, right, this would be, B over A, 1, 0, C over A, 0, 1. So actually we're not doing too bad. So we just need to have a eigenvalue, A plus B plus C, that is going to give us just 1. So we can't have it be more. So we'll do A minus A plus B plus C. So that'll be minus B minus C. B, that'll be minus A minus C. And then this one minus A minus B. Okay, now becomes the mildly hard part. We have to get a basis sort of out of this, right? So this is when we've plugged in our eigenvalue, which is A plus B plus C. And yeah, you know, it's not looking too hot. We would have to row reduce this to find the null space, right? So definitely not the most fun thing to do. I'm trying to think about how this could be a little bit easier. Can I rearrange it so that it's the constants? No. Maybe I can. So if we have minus bx minus cx plus by plus cz equals 0, we have ax minus ay minus ac minus cy plus cz equals 0, then ax minus plus by minus az minus bz equals 0. We can group this potentially by the b's instead. So we would have, if we had b, that would be negative x plus y and plus c negative x plus z. I don't know if that's helpful though, but you know, it's an interesting question, so I'm gonna pursue it a little bit more. Minus c or plus c, that'd be minus y plus z, and then a. Because if we had these in a matrix, but we're trying to solve for the constants, right? So it's kind of hairy if you think about it. Right, so if we have a here, then we have x minus z plus b y minus c. There's not a lot in common. Oh, my big head is in the way. Still in the way. Not a whole ton in common here. I'm not seeing it. We could also do... God, you know what they might want us to do? Chat. Solo. They're gonna have me stoop. We'll do it the fucking secret trick way. I think that's what they want. Because if you do minus the trace, so that would be this plus this plus this. That'd be minus 2 times, sorry, plus 2 times a plus b plus c. X squared. Minus this determinant, I think. And then this one, and then the outer corners. God, it's just so, like, I don't even know how to... did I do that out, or did I just write it? I think I was just so mad that I didn't even write out which determinants. Let's see. And we can play some craft after this one, I think. Where did I do this actually? You've paddled 2,000 meters? You went 2,000 meters? Holy shit. I was so mad about the secret trick. Yeah, I don't know. I guess you just add all the determinants? Oh, Astroneer is not on sale? That's okay. It's probably not that much. I really want to play it. I think I want to get it in the summer, so like I can get into it in the summer and then like actually play it for like a long time, because I feel like that would be such a good Damie stream game. Like such a good Damie stream game. Wait, this times this? That sucks. Why would I do that? This sucks maybe worse than the other one. Oh god, I'm not solving this. I technically just don't have to. This is like 1% of my grade. Alright. What are you thinking, chat? Do we do one more? We do one more, or like... Do we want to play some Minecraft? I have B stuff I can show. I've been working on some B stuff. I've been working. Oh, yeah, 41 is easy. Want to see some bees? Fuck yeah. Okay, let's do some Minecraft then. It's gonna take a sec to boot up. So while it's booting, we can maybe just do this one, because it's actually kind of interesting. This one is also interesting. This one's just not as much of a stream one, because I'm probably just gonna have to sit quietly and stare at it for a little bit and see if I'm doing it the way that they want me to do it. It just kind of sucks that there's like a way they want you to do it, but... Creepers? Aw man, hell yeah. I can't wait till I can get home, because then I can actually do the coding part of the FTB stuff again. Because I miss my robots, I really do miss them, but I just can't... Like, bees are so easy, and it's so much easier for me to do them. I have made leaps and bounds in the bee technology, guys. You just wait. Just wait. You haven't seen the Bee Dome TM yet. It's been a while since I streamed Minecraft. I've been playing it the same amount, so... Oh, it's so sad when I, like, have to go to classes and I can't play Minecraft. Okay, this question is asking to plug in a matrix and determine the... Can I solve cancer with bees? In real life? No. In Minecraft? I think that's a question of, like, whether regeneration in Minecraft would solve cancer. Do you think regeneration would cure cancer? Good question. I think it's a fair question. Okay, this is a matrix of literally all ones. No, because then you just end up like Deadpool. But like Minecraft characters, like you don't lose limbs or anything. You get super cancer? Wait, why did this do eigenvalue? What? Why did that do Gauss-Jordan? I asked for the eigenvalues. Hello? I don't know why it did that. Eigenvalues, please. Please, please. Super cancer. Okay, so there's 2 eigenvalues. I'm gonna spoil it. It's just 1, 1, 1, 1, 1, 1, 1, 1, 1. Which is a funny matrix. And then lambda equals 3. Depending on how this could work out, you would actually have... So for the lambda equals 0, you would have 1, 1, 1, right? Because you row reduced. That is the worst RREF I've ever written. RREF. So then you have 2. You have negative 1, 0, 1, 0, and negative 1, 0, 1. And then for lambda equals 3, you have fucking, I don't know, I don't really want to do it, but negative 2, 1, 1, negative 2, 1, 1, 1, negative 2. And then you could go and, you know, fix some stuff, and it seems like you'd probably get 1 eigenvalue, so dimension equals 3 eigenbasis. Or it's not, and then, you know, it's not. Oh, so it is non-defective. I think all matrices are non-defective. I don't think there's such thing as a defective matrix. Why are we being so mean to the matrices? Tell me that, huh? Why do we create such things if we're just going to call them defective? You bet I'm diagonalizable? Oh my god, best compliment. I could be diagonalized, I think. think that every human could be diagonalized, let's be honest. I mean, I'm an angel, but I think every human could be diagonalized. You just gotta understand their basis, okay? See, chat, if you actually learn linear algebra from me, then you can understand all my, like, philosophy ramblings, because I can say something like that, and you're like, oh shit, I kinda get what he's talking about. Because literally all of my philosophy I talk about, like, in terms of math. Certain Florida men are not diagonalizable. That's funny. Yeah, they're just a higher power, actually. No, I think they're super easy to diagonalize. Very predictable. Very, their eigenvalues are on their sleeve. It's still loading, by the way. I'm not just, like, sitting here. I'm eating a cookie, though. Are we nerds? Yeah. But, like, Star Wars used to be, like, a nerd thing. And now, like, everybody knows about Star Wars. What kind of cookie? A Milano. Little cookie. What other games should I put on my list to stream, chat? I feel like I should, I feel like I should put some more Minecraft. What's up? I feel like I'm just gonna say, like, oh yeah, I'll play games, and then I end up just playing Crush and Minecraft the whole time. Crab Champions? Oh, that game actually looks fun. Demonologist? I've never heard of that game. For the King? Oh shit, I heard that, but like... I think I heard about Germa doing something like that. Ultimate Chicken Horse? I am so bad. I don't rage quit many games. I can't play Ultimate Chicken Horse without getting irreversibly mad. Okay, let me get to safety and away from the B-dome real quick. And I'm gonna change my category. Can't be streaming in linear algebra. Minecraft. It didn't work. Okay, awesome. I love that. That worked. Sounds like a skill issue? It absolutely is the thing. I will not debate that. I'm just... Yeah, it is a skill issue. Okay, and change my category. This is such a specific stream name. I love having, like, just specific, really way too specific stream names. Because I feel like I see them and I'm like, oh yeah, that's... I would click on that stream. Okay. What have I even done? Okay. I made my house a little bigger, as you can see. Because I want this to be like an Amazon fulfillment center at some point. Not like that. That's not the word, but the words are not coming to me. This was gonna be like the lobby at some point. But also my portal's down there, like, you know, I just kind of need to be. It's funny because I put these windows in, and now I don't use the door, I just walk through the windows, so... You can begin to see my empire of bees, at this distance. I have made what I affectionately refer to as the bee dome, but in reality it is more like a bee funnel. Where do I even start? Every empire falls. Careful, bees will never fall. They fly. Anyway, my hubris is unbounded. This is one of the best things I ever did, was put an ender chest here that leads directly into a bunch of stuff. As you can see, things disappear when I put them in here. Where do they go? I don't know. I'll show you guys, though. I'll show you guys. So we have I still have my hybrid stuff. A lot of the queens that I have around, oh my god, why do I just have these? Why have I not converted these to anything? I was gonna say, a lot of the queens that I have around are ignoble stock, because ignoble stock means that bee can get used up. So I try not to keep any of my actual genetic stuff on bees that are ignoble stock, because pristine never die. And when you're doing what I'm doing, you'll see why it makes sense. Okay, this is my new chest setup. A lot of these are empty, but as you can see, this is my production line of drones. Just so many drones. Just so many drones. Just stacks upon stacks of drones. It's not loading, but it is a little laggy. I have a lot of bees. Lots of different types of bees. As you'll see, there are some new types of bees, which is the most exciting part. And I'm sad that I didn't get to do it on stream, but also I'm not sad because it took me a really long time and a lot of headaches, and honestly, it's just better to see the stuff after. This is, okay, thank you, server lag. Thank you, server lag. This is one of my pride and joys. I do want to make a video on how to do this setup, because if I didn't have this, it would be so annoying to try and breed bees. When you're breeding bees, you're gonna eventually get to a point where you like fuck up your queen. You're playing some Division 2 while silently judging your beedom. Absolutely, no worries. I love my bee setup so much. These are a lifesaver. These like will convert a bee that you fucked up back into the pure version of the bee. And I think I've showed this setup off before, but I made some extra ones. I have one for Noble. That was the last one I had. I have one for Diligent. And this is my industrious conversion center. Okay, it really is laggy. Maybe I should do a server restart. Yeah, this is pretty rough. Okay, yeah, okay. Well, we can do a little tour before I restart. So this is my B-dome. TM. Lots of apiaries. You can only do apiaries. We tried, Umbra and I tried for a long time to try and figure out how to automate bee houses. The developers did not put them in as a block that you could interact with whatsoever, so the only way I'd be able to do it is if I had a turtle and then I broke the block and then the turtle sucked up the bees, and that was just like way too much effort. These are all fully automated, as you can see by the little pipes set up here. These are dense item ducts, so what happens is, I can show you over here, this is my Alviri production side. You can see, once the drones get produced, they'll always have a stack in here, so the overflow of the drones go to this chest. It's a big chest, and you can see I have some stuff waiting for me. Probably the biggest achievement that I managed to have, which is incredible. I still can't believe that I did it. I got the stuff to make the Alviri, which is insane, because I've been trying to do that for months, and I thought you just needed royal jelly, but it turns out you don't just need royal jelly, you also need what's called a pollen cluster, which is not a trivial thing to get either. You need a tier 4 queen to do that, which is industrious. So I have imperial and industrious. And I can get royal jelly and I can get pollen clusters. And I still cannot believe that I can actually say that, because holy shit, that took me so long. Like genuinely a ridiculous amount of time spent doing that. Just breeding bees. So over here I have all of my, these are all of my like hives for genetic stuff, I guess is the best way to put it, like actual crossbreeding. And then up here are the stabilizations, which you can see from the one that says imperial stabilization, because when you get a bee, they can be pure, but they don't necessarily put out the exact same type of bee every time. So I try to stabilize the genetic line before I put them into any sort of automated feeder, because it just, I don't have to worry about like having a bunch of different random copies of drones. Like I only have to worry about getting the actual drone. So the cool thing is, one of the cool things is I could probably make the engineer bee right now, which is the whole reason I started breeding bees. And it's very funny to me because the engineer bee is actually really easy to make, and I didn't actually have to do any of this stuff, and I just didn't know how it worked. And it took me a while to figure out how it worked, because so the engineer bee is a bee that I wanted to make because it's called an engineer, and it's PhD in a noble. And PhD is stuff I couldn't figure out how to make a student. And it says, requires oak bookshelf as foundation. And I thought that was in the alveary, right? The alleviary, as I call it, because I put in extra letters. I thought you had to put it into a block. And it turns out you don't. What you need to do is you need to take a beehive and you need to put a bookcase under it. That's all you need to do. So I could have just made the engineer bee, and they're like really easy to breed because like the percentages are like 50%, you know, like 25%. Whereas like some of the stuff for, you know, regular bees is like 8%, 16%, 2%, you know, so kind of rough. Not really my finest moment. But to be fair, there is not a lot of information on bees, so I'm gonna send a restart to the server because it's kind of lagging a lot, and that's like a lot. Let me pull it up real quick. And I'm also gonna grab a thing, so. Let me just also look at the RAM usage. It might be like a lot. Oh yeah, it's a lot. Kind of rough. Because we also have chunk loaders on, which is like fine. I'm fine with it because, you know, if it's only me and, you know, people I know on, like, you know, I don't care if the server's like laggy. And also, me and Umbra both play a lot, and we both have stuff that we just want like running. For accumulation reasons, like for bees, it just takes a long time to stabilize genetic lines and stuff like that, so if there wasn't chunk loading, it would be like way too long to do all that. It would really have no life, but you know, this kind of helps a little bit. Where did I put that? Oh, there it is. Anyway, that's the update on the bee situation. Pretty good. Once I have my Bobot army, it'll be easier to do stuff as well. I honestly might not play that much. I might play for just a little bit. Because for bee stuff, it's kind of like I just run around and like do it, and I kind of just like brainlessly do it, but oh, I added a bunch of, well, what's the best use of time? Oh, it's still starting. Lol. I guess we can see if the Imperial one is still stabilized. I think I need more. We can make some more apiaries, because I kind of need more for my, Alviri production in general. Just kind of like... You need like 217 of these panels, and like each one takes like a royal jelly and like like a pollen cluster and like a bunch of beeswax, so... I did not anticipate getting it after like getting it, because you need to make a 27 block structure, so... It's kind of a lot. It's kind of expensive. So I need to upskill production. Let's see. Oh my god. Still restarting, this is so sad. I'll get there.